You know, when you first look at it, Messier 2 seems almost perfect. It's this beautiful, glittering jewel box in the sky, a dense, ancient ball of stars that looks like it's been the same for billions of years. But if you look just a little closer, this peaceful sphere of light tells a really violent story of galactic cannibalism. So yeah, let's dive into this cosmic cold case.
Okay, first things first, a quick refresher on what we're looking at. M2 is what's called a globular cluster. Basically, think of it as a star city, a massive, really tightly packed neighborhood of ancient stars all born around the same time, and now they're all orbiting the core of our Milky Way. They're supposed to be pretty simple things, almost like a single snapshot from the early universe.
And yeah, on the surface, M2 totally looks the part. It's hanging out in the constellation Aquarius, about 55,000 light-years away, and it's got something like 150,000 stars packed into it. It really seems like a textbook example of a globular cluster. But that's exactly where the simple story just falls apart. Because when astronomers pointed their most powerful instruments at M2, they found out this perfect little sphere is hiding some seriously bizarre secrets. So our first clue that something's off comes from the stars themselves. See, a normal globular cluster should be pretty uniform, kind of like a city built all at once with the same materials. But M2, well, it's not like that at all. What's just so wild here is that M2 isn't one big happy family of stars. It's actually made of at least 3 distinct groups. And these groups have different chemical makeups, what astronomers call metallicities. It's as if different parts of this star city were built from totally different kinds of bricks. And for a globular cluster, that's just really, really weird. They're supposed to be chemically simple.
The best way to picture this is with the historic city analogy. Component A, which is almost all of it, that's like the ancient original old town. Then you've got Component B, a smaller district built later with different, heavier materials. And then there is Component C, this tiny modern part that just doesn't seem to belong at all. So how on earth did one city get built in so many different phases? Let's hold that thought.
Okay, so the inside is weird, but the outside? That's puzzle number 2, and it's where things get really mind-bending. M2 isn't just a city. It's a metropolis with this huge, ghostly suburb that absolutely should not be there.
So, based on all the standard models of gravity, M2 should have a really sharp edge, about 12.5 arc-minutes across in the sky. This is its tidal radius. It's the point where the Milky Way's gravity overpowers M2's gravity. Any star that wanders past this line should just get stripped away. The city should have a definite wall, right?
But that is not what we see, not even close. Instead, observations show this massive, ghostly envelope of stars stretching out to at least 60 arc-minutes. That's almost 5 times larger than its gravitational boundary. Where did all these extra stars come from? And how are they possibly still hanging on?
And this, wow, this slide just lays it all out. On the left is what we expect to see, the king model. See how the number of stars just drops off a cliff at that boundary? But on the right is what we actually see, a power law model, where the stars just slowly fade out into this enormous spread-out halo. And here it is. This is the evidence. This density map shows that bright packed core of M2 right in the middle. But look at that. It's surrounded by this huge, faint, reddish glow. That glow is the ghost, that giant stellar envelope that just defies all the conventional explanations. Okay, so we've got 2 huge mysteries. A weird mix of stars on the inside and a giant halo of stars on the outside. Well, the solution comes from a completely different cosmic event, one that has a pretty funny nickname, the sausage.
So it turns out M2's orbit and its chemical signature link it directly to this massive river of stars called the Gaia-Enceladus sausage. This sausage is actually the shredded remains of a dwarf galaxy that smashed into our Milky Way billions of years ago. M2's path through space isn't like a native object. It's an immigrant, a survivor of that ancient collision.
And that one single fact, it solves both of our mysteries at once. It means that M2 isn't just any globular cluster. It's something way, way more profound.
The scientists who mapped out M2's halo put it perfectly here. It's not just a cluster that belonged to some other galaxy. No, M2 was the heart of that dwarf galaxy, its dense central nucleus. So let's piece this whole story together. You have this small galaxy with its own complex history of making stars, and it falls into the Milky Way's gravitational trap. Our galaxy's massive gravity
then just tears it to shreds, scattering most of its stars all over the place. But the core, the densest part, was tough enough to survive. And that surviving core, that's what we see today as Messier 2.
And suddenly, it all makes sense. Those multiple populations of stars inside, that's just the preserved history of the original dwarf galaxy. And that enormous, ghostly halo on the outside, those are the leftover stars of the parent galaxy, still faintly clinging to the nucleus that used to be its heart. You can see it right here, the dense survivor on the left and the phantom of its former self on the right.
So the story of M2 isn't just about one cool object out there in space. It's a key piece of evidence that reveals the true and pretty violent nature of our own galaxy's past.
What this all means is that M2 is basically a cosmic fossil. It's direct proof that the Milky Way's halo is like a graveyard, built piece by piece from the cannibalized bodies of smaller galaxies. Our galaxy wasn't just born one day, it was assembled through a long, violent history of eating its neighbors.
So, the next time you're outside and you look up at what seems like a peaceful, starry night, remember the story of Messier 2. It really makes you wonder, doesn't it? How many of those other little sparkling dots in the sky are actually the ghosts of lost galaxies, hiding their violent histories right in front of our eyes?